Welcome to The Explainer, everyone. I'm absolutely thrilled you're here today because, well, we're tackling one of the most misunderstood challenges in the tech world right now. You know the exact feeling, right? You built this really cool AI demo, it works flawlessly on your laptop, and boom, you think you're ready to ship it. But here's the reality check. Treating AI like a simple demo leads to massive, highly visible, and honestly very expensive real-world failures. Today, we're exploring a fascinating framework designed to fix exactly that. We're going to see how to build AI agents that actually survive real-world deployment.
So, I want to start by asking you a crucial question. When you kick off an AI project, are you choosing a model first? Like, are you sitting there debating whether to use GPT-4, Claude, or Llama before you've even laid out your basic system architecture? Well, if the answer is yes, it turns out you've already fallen into a massive trap. Obsessing over model selection right out of the gate is the exact reason why agents break when they hit the real world. We literally need to completely flip our perspective on this. Okay, let's dive into this and look at Sandeep Bhaumik's framework for production-grade AI. We're going on a rigorous 5-layer system design journey today. First, we'll look at the production trap, then move through layer 1, evaluation metrics, followed by transparency and reliable data, multi-agent orchestration patterns, governance and risk management, and finally, we'll wrap up with the incident response playbook. All right, starting off with section 1, the production AI trap, from demo to disaster. It is absolutely essential for software engineers and founders to shift their mindset away from clever prompt tricks and toward real operational discipline. Listen, relying on some clever prompt engineering might get you a viral demo on social media, but it is definitely not going to build you a sustainable business. This framework points out a really hard truth that we all need to hear. A model is not a production system. It's just not. It's literally just one tiny component within a much larger machine. Deploying enterprise-scale agents requires a strict, rock-solid engineering foundation built across 5 distinct pillars. And if we ignore even one of these pillars, well, the whole system is at risk of collapse. So let's look at the very first pillar we absolutely have to construct. Which brings us to layer 1, evaluation metrics, or the specification layer. The absolute first step here is defining your numerical success metrics before you write a single line of code. Think about it. The first real step in production AI isn't coding. It's defining success. How do we actually know our agent is doing a good job? Well, to measure that, we have to build what's called a living golden data set. And this isn't something engineers can just do in a vacuum. We need to sit down, collaborate with domain experts, and really dig in. We have to gather real-world edge cases, those weird, unexpected user inputs, and outline the exact expected outcomes for our system to measure against. And we call it living because as your product evolves, this data set has to grow right along with it. It becomes your anchor. And this brilliantly illustrates the 3-layer automated testing strategy we use to test against that golden data set. First up, we've got deterministic checks. These are your simple binary tests like checking for correct formatting or making sure absolutely no personally identifiable information or PII is leaking out. Second, semantic checks. This is where we use an LLM as a judge to evaluate if the answer is actually grounded in facts and safe to show the user. And third, behavioral checks. We're monitoring how efficiently our agent uses its tools and ensuring it doesn't get stuck in some crazy infinite loop. The fundamental rule here, if you can't measure it, you cannot ship it. Period. Moving right along to layers 2 and 3, transparency and reliable data, focusing on observability and data foundations. Because, unlike humans, agents absolutely do not forgive bad data, and they require total operational visibility. Look, agents basically operate as complete black boxes unless we forcefully drag them into the light. We literally have to be able to account for our AI's behavior at 3 a.m. when we are fast asleep. This is what we call the transparency layer. If you are working in a regulated industry, audit trails aren't just a nice-to-have feature. They are legally mandatory. We need to trace every single decision the agent makes. We have to capture its full chain of thought, log those confidence scores, and record every single API interaction. Why? Because when something inevitably breaks, this tracing is our one and only lifeline for debugging why the agent decided to serve a terrible answer to a user. To actually achieve that level of transparency, the framework shows we need to clearly distinguish between 2 very different types of data in our system. On one side, we have question data. This is your serving data, think RAG systems and knowledge bases, that actually give the AI the context it needs to answer the user.
On the flip side, we have tracking data. This is all your monitoring and tracing logs. It is so crucial not to mix these two up. Both of them need to be optimized and scaled completely independently if you want to maintain a healthy system.
And speaking of data, I want you to remember this equation. Bad data equals confident hallucinations. It's that simple. AI systems are literally only as reliable as the data foundation they stand on. Welcome to the reliability layer. If an agent is pulling from outdated or messy files, it's going to confidently lie right to your users' faces. We absolutely must implement heavy data governance tools, think things like Unity Catalog, to strictly manage permissions, ownership, and metadata. It's honestly fascinating how critical it is to ensure your agent is retrieving context exclusively from clean, strictly governed sources.
All right, next up is Section 4. Multi-agent orchestration patterns, which is the architecture layer, because scaling from one single agent to many introduces, well, exponential complexity into the system architecture.
Now, what's really interesting about this slide is how it breaks down that complexity. Building one agent is relatively straightforward, right? But when you scale up, they have to talk to each other, hand off tasks, and share memory without completely breaking down. So here are the 3 core architectural patterns to manage that chaos. First, the orchestrator worker pattern. This gives us central control and high auditability, perfect for those complex step-by-step sequential tasks. Second is choreography. This one is best for parallel processing, where we need low latency, independent agents that just react to events on the fly. And finally, human in the loop. This is absolutely vital for critical workflows where the AI's confidence level falls below a certain threshold. The major takeaway here? Your architecture has to match the specific workflow of your business, not whatever AI hype happens to be trending on social media today.
Let's move on to Section 5, Governance and Risk Management, the risk layer. Here, we really have to treat AI as a living product that necessitates ongoing change management and strict risk mitigation.
It's never just set it and forget it with AI. A foundational practice here is treating prompt as code. For the technical folks listening, this is exactly how we bridge traditional software engineering practices with modern AI development. We learn that we need to version our prompts exactly like we version application code. You should be documenting the reasoning behind every single prompt tweak right there in your Git history. Because if an agent suddenly starts acting erratically, we need to know exactly who changed the prompt, exactly when they did it, and most importantly, why.
Furthermore, think about this. Model providers are constantly releasing updates. GPT gets an update, Claude gets an update. It literally never stops. When that happens, it's so tempting to just switch over to the shiny new version, right? But the framework stresses that regression testing is absolutely mandatory. You have to test that new model against your living golden evaluation dataset first. We have to definitively prove it meets our specific enterprise standards before swapping it out in production. Just remember, AI is never truly done. And that brings us to our final section, the incident response playbook, turning theory into action. This is the highly practical finale where we cover exactly what to do when an agent fails in production. Let's move to and see how this builds into a tangible framework you can implement literally today. Because we've talked a lot about preventing failure, but in the real world, things are eventually going to go wrong. Here's the playbook. Step 1, detect. We need a live dashboard that screams at us the second our metrics drop. Step 2, diagnose. We jump straight into those tracing logs we talked about earlier to see exactly which API call or thought process went rogue. Step 3, contain. We immediately route the workflow to a safe fallback or a human in the loop to stop the bleeding. And step 4, fix. We don't just go in and tweak a prompt, we add that specific failure as a brand new edge case into our living evaluation test cases so it literally never happens again. I want to leave you with this provocative thought to chew on today. Take a hard look at your current projects and ask yourself, are you building a rigorous production system, or are you just relying on a prompt trick? True production AI is a deep operational discipline. It absolutely requires evaluation, observability, a solid data foundation, proper orchestration, and strict governance. If you apply these 5 pillars, you're going to build agents that don't just demo well, but actually survive and thrive out there in the real world. Thanks so much for joining me on this explainer, and I will catch you on the next one.